Good morning. Today we're going to practice a lot of what we did yesterday of domains and ranges and recording it correctly. You got to know the difference between a discrete graph and a continuous graph so that you know how to record domains correctly. These guys right here are discrete graphs because they're individual dots. But when we get down to here, this is a continuous graph. And so continuous graphs have inequality signs because we have lots of points in between that are solutions. And then on continuous graphs, they're individual dots. So this whole first page here should take you a little bit of time. It's the warm-ups. This is what we did yesterday. A couple suggestions before you pause your video is over here on number 2 when you have to make a mapping diagram. I would say the easiest way to get your x's and y's is to make these coordinates into, even though they didn't say so, is make these points into coordinates here. And so kind of come up with some kind of a system that you make sure you get them all. Like that coordinate's called -2, -3. And so you might just kind of write these nearby. That dot's called -2, 0. That coordinate right there is called -1, 1. So that way, when you're all done, you can just compare all your x's here in this row and put them in your mapping diagram for your x here, and then put them in order from least to greatest. And then you can compare all your y's and put them in the second bubble and then draw your lines. That was a mistake on yesterday's paper that I was grading, is a lot of kids that turned their paper in from lesson 20 didn't make their connections from the mapping diagram. They just wrote their x's and their y's here. So make sure you do that. We'll talk more a little bit here in a little bit, but I want to see how you do on 5 and 6. So pause your video and then come on back and I'll have the answers here and show you some more about these problems here. Okay, so let's go to the answers here. This first guy here, plotting all the points. Sometimes kids, if they haven't graphed for a while, they forget how to plot points. But these are my x's here, and so this is the coordinate called -1, -2. So that first number means you go to the right or left, so you went left -1 and down 2 because they're both negatives. That's a coordinate +1, so that means we go to the right one. If I want to graph this guy, then to the right one, down 1. Okay. This was not, and this is what I'm looking for on a mapping diagram to see if it's a function. Right there, I have 2 lines coming off of this guy. So that means it's not a function. You can't say, well, I guess you could here because you have a graph. You could say it doesn't pass the vertical line test because you have a graph here. But another way to say it would be the domain of 1 has 2 ranges of -1 and 0. Your domain, they did this paper correctly. They're all in order here in your mapping diagram, but it is a discrete graph, so it goes inside of brackets. Some kids yesterday, 2 kids, put a bracket like this. This has a totally different meaning in math than a bracket like this, okay? And it's not a parentheses because that's what we put coordinates in, things like that, okay? So we're starting to get brackets and parentheses and things like that are different, but these have different meanings, okay? So it's definitely do your best to draw a little bump there with a point in there to make it a bracket. I have a hard time sometimes, especially with this pen, drawing them, but it should be a bracket, okay? So there's those answers. This one here was not a function either. Right there would have broke the rule if you did the graph and say vertical line test, because I have a graph, I can do that. But if you use the mapping diagram, right there is the guy that broke the rule. Okay, so you need to know how to do both. Excuse me. Here's another one of the mapping diagram, not a function again, because now I don't have a graph, so I can't say down here doesn't pass the vertical line test. Some kids are saying, well, the domain has 2 lines. Well, that's what I'm thinking in my head. The domain has 2 lines coming off of it, but that's how I'm telling, but that's not what I can write down here. I need to say the domain of 1, he's the guy that broke the rule, has 2 ranges of a -2 and 0. That's the guy that broke the rule. Down here on my domains, it's a discrete graph again, so I'm going to have a bracket. My x's were in order nicely, and my y's were in order. So that paid off. Over here, we do have a function, passes a vertical line test. Again, I can say that because I'm looking at the up and downs here. They asked you to write them as a set ordered pair. So that's these guys over here. And they said, not a table. This is a table. Okay. There's my domains and ranges down there. Make sure you put commas in between each one so that I don't think like this number is a 12. It's a 1 and a 2. Okay. Now, these guys down here, I wanted you to give a stab at it. First of all, it's a continuous graph. Oh, let's go back with its function. Well, it passes the vertical line test. So yeah, it's a function, passes the vertical line test. But now, when I go to my inequality, I have to have an x in it because it's a continued graph and its domains are x's. But now, on the x-axis, this is where my graph starts at -2. So I got -2 there, but it's an open circle. So when I say x is greater than -2, that's how you read it, from middle to the left. I don't want the or equal to sign there because I have an open circle. Up here on the x-axis, my graph ends at 2, but it's a solid dot, so I want it. So what this is saying is I have x's hitting my graph in between these two guys, -2 and 2. Okay. Now when I go to the y's, I put the y in the middle, and then I start at the bottom of my graph and start looking left and right. My bottom number right here is also -2. It just happens to be here. It's an open circle, so I want no or equal sign there. And then as I go up, my graph tops out, or the top of my graph is right here at 1. But that has that solid dot, so I want the or equal to sign. Okay? So now you got to kind of pay, this is kind of growing a little bit, is open circle versus closed circle. Okay, as part of my graph. This is kind of what we're getting ready for science. Physical science, you do sound waves and things like that you have graphing. This isn't really a sound wave, but they start curving like this up and down. It's a function, passes the vertical line test. Now when I go to do my x's start right here on -2. So that's my lowest number. Keep hitting my graph all the way up here till 2. That's my highest number. But when I hit this, it's an open circle right here, so I don't want the or equal sign. And when I'm down here, I have an open circle, so I don't want the or equal to sign. Okay? But now, kind of a little bit trickier is when I do my y's. Got to be a y here, because that's what range means, my y's. I start way down here at -4, but if I look at my line here, it's not a dashed line, it's a solid line. So I want the or equal to sign. As I go up, a lot of times kids will say my graph ends right here at -2, but that's not the highest point on the graph where my graph goes. Yeah, it does end there, but my highest point on the graph is up here. And so that's at 0 on the y-axis, and I have a solid line there, so I want the or equal to sign. Okay, so just growing a little bit there. All right. On the back side, here we go with the circle here. Doesn't pass a vertical line test for sure, and this is a graph, so I can say that. X is my domains, and so my graph starts right here at -3. Starts hitting my graph right there, and it's a solid line, so I want the or equal to sign. I keep hitting my graph along the x-axis until right here at 1 on the x-axis. If I'm looking at my y's, now I'm going from the bottom of my graph and I'm heading up. So right here is where the bottom of my graph is, and that's a -1. Keep hitting my graph all the way up until up here at 3. Again, it's a solid line right here and a solid line up here, so I want the or equal to sign. Okay. Now, this is where we're starting to get into some new stuff here, because this was not on our papers the other day. This thing called an f of equals. All this means is a function, and that's what we're learning today is function notation, and how to read function notations. And because you're watching a video today, this comes a little bit easier. We still have these from yesterday that they said, give me the domain and range. So again, the domains are the x's, and so I got these guys right here. I want to look at them and put them in order from least to greatest. 4, 5. Sometimes I'll put a little check mark up here to make sure I got them all, as I list them down here. That might be a helpful hint. And then when I go to my ranges, that's my y's. So there's a 7, a 4, a 3, and a 10. 3 is my smallest, then I have a 4, then I have a 7, and then I have a 10. Now, you don't see my wall in my classroom, but there's a list in my wall that says all the different names for a y. And we kind of, through the years, y means y, obviously, but then we also said it's output. Yesterday we said y's are also named for range, but we also have this thing that's called functions. And so if I have an f of x like that, that really means the same thing as a y. I could say h of x, and I have these listed on my board, a g of x. All of these things is what makes algebra a little bit more challenging for kids learning algebra. All these things mean the same thing as y. You also would see on my board where we have something like this, y equals 3x plus 4. And all along your teachers kept saying, get the y by itself, get the y by itself. And then we can graph this thing quickly with a table or kind of saying that's my y-intercept, there's my slope, but we always want the y by itself. Well, same thing, except for now we're going to write f of x. That's what makes it a function. That's the only thing that's different. That makes it a function. Crazy name for the same thing as an equation. Okay? But that says the exact same thing as that guy. It's just instead of a y, we have f of x. Now, what we have to know is, oh, by the way, they could say f of h in parentheses here. All that means is instead of an x in my equation, I would have something like this. If I had f of h, then my equation would say something like this, 3h plus 4. I'd have h's in there. Now, if there's no number or letter there, but I have a number like this, I know there's supposed to be a letter behind that 10, probably an X. So what I'm doing is I'm looking for my X up here in my data that is the 10. And they're really asking, well, what's the Y value equal? What's the whole thing equal if my X is a 10? So I come up here and look and find my 10. There it is right there. So this is how easy it is. What's my Y value? 7. That's the answer to that. F of 10 equals 7. All I did is looked at my data to where the x was a 10 and found my y value. As soon as my pen starts writing here, there's the answer for that guy. That's how easy it is. Let's do our domains and ranges. It's dots. It's points on a graph, so I know it's a discrete graph. They did it right. It's in order. -3, -1, 0, 1. So that makes my domain really easy. Now my range, not very often is this in order because you can't control this over here on the table. So you just got to kind of look and see who's the smallest number. Looks like it's a 0. And then I have a 1. Even though I have two ones, I only write it once. And then I have a 3. There's my range. Now, so this keeps coming up over and over and over, but this is the new thing. There's my f of x. It's supposed to be an x right there, but they said x is a -1. So I'm going to come up to my table here and look for my x that's a -1 and find my y value. It's a 1. No math involved in this part so far. That's how that works. That's how it's easy. Mapping diagram. We can still find the f of 3, but let's get our domain and range out of the way. Here's my domain. Everything's in order like it should be from least to greatest. Makes our our domain graphing, it makes recording my domain and range really easy when I put these in order. They're already in order. They're already written one time, even though, nope, this is a function. There's one line coming off of each one, but it makes this go a whole lot faster. I have a -2, I have a -1, and I have a 0. There's my range. Now, let's come up here and find the x that's a -3. There it is. Let's follow it to find out what our y value was. It was a -1. Final answer. Okay? A lot of times what we'll have is math an equation where they'll say f of x equals -3 or find f of x is -3. And so that's going to be what's on our worksheet today. Okay? All right. Here's another one on these domains and ranges that when they give dots like this, I don't want to have to take the time like we did on our warm-ups and write all these coordinates. So another way to do this quickly is I start from the left on my domain and looking on my x-axis, and I keep looking up and down. Whenever I hit a dot, if I start on the left, then they'll all be in order. For example, right here, I'm looking up and down. There's a dot right at -2. I keep going over this way. I see a dot right there. On the x-axis, it's a 0. Keep looking up and down. There's one at 1. Continue on. There's one right there. It's on 0 on the y-axis, but it's still on the x-axis at 3. And so sometimes that helps as far as getting them in order in a quick fashion. Okay. Let's see if I can figure out when I have a big mouse like this, sometimes it doesn't like it. All right. So now when I go to my ranges, I'm going to start at the bottom and I'm going to look left and right until I get to a dot. I see one right there on the y-axis. It's a -1. Keep looking left and right. There's one at 0 on the y-axis. Keep looking left and right. I see one there at 1. And then I see one right there at 2. Close my bracket. So now this really is supposed to say f of x. But now we know how to read functions. There's supposed to be an x there, but there's a 3. So that means go to the x-axis, find your 3. Which this one's a little weird. There's my 3 on the x-axis. What's my y value for that point? It's a 3. Or no, I'm sorry, 0. The y value. If this dot was up here, let's pretend it's not here, I'd still go to 3 on the x-axis, and then I'd go up and find my dot. It's right there. Well, what's my y value for that dot? Then in that case, it would be a 1 for this one. Okay? Here we go now. Continuous line. Now we have a little bit of a weird kind of compound inequality for this one. It's a curved line, but we still have a domain and range. They could ask us if it's a function. It's a function, passes the vertical line test. But now I have x's that start right here at 0. My graph starts at 0, so that's my smallest number. And I keep hitting my graph on the x-axis all the way up here to 8. So that's my highest number. So now I need my inequality signs. And again, if I put the smallest number here and the largest number there, they'll point to the left. I want x greater than 0. I start here at 0 and I'm starting to head this way. But I also want all x's less than 8. So my x's are all in between these two coordinates now. So now I got to look here about my or equal sign. When I have this 0, I have a solid dot, so that includes 0. But when I get to this side, I have an open dot, so I don't want the or equal to sign. It doesn't include 8 on the x-axis, but 7.999 works. Okay. So now we got to start paying attention to open circle, closed circles. Now when I go down to my range now, it's going to be a y in the middle. And so now I'm looking at the y-axis and I start again from the bottom looking up left and right. It starts at -3 is where my graph starts. I want to worry about my signs here in a second. And a lot of kids would say, well, it stops right here at -3. No, it doesn't. I'm still hitting my graph up here. I come all the way up here on the y-axis to where it stops, which is a 1. So now I have to find my inequality signs. So right here is a solid dot if I look left and right, and here's an open dot. A solid dot overrides an open dot. So I want to include -3 because it includes it right there, even though it doesn't include it over here. So I want the or equal to sign. As I go up to the top here, this is a solid line. We don't think we've had a dashed line yet. But if we had a dashed line like that when the dot was on it, would be an open circle. But I don't. I have a solid line. So that means I want a solid line over here. Y is all numbers less than 1. Well, there's 1, and I want all the y's that are in between these two guys, -3 and 1. Now, let's clean this all off here, and let's go find my f of x. So now my f of x, they said, is a 0. So I go to the x-axis and find 0. Now I go up or down to find my graph. It's right there. There's where my graph is. I want to know what my y is for that. It's a -3. Okay. We're going to grow here a little bit on this one. This one's a little bit tricky. There was supposed to be an arrow right here. Most of your graphs in 8th grade had arrows. When you did linear lines, you were told to put arrows on both ends because the line extends in both directions to infinity. Well, this guy goes to infinity too. So when we do our domain and range now, we got to be a little bit careful because we have a starting point and a stop, or we don't have a stopping point over here. So it's not going to be a compound inequality like this, but it's still going to be an inequality. Okay. So we know domains are x's, but look at my x starts right here on the 1. And if I keep going across, I hit my graph, Even over here, I hit my graph. And even though out here, I'll eventually hit my graph because this keeps getting more and more to the right. So I could be like 2 miles to the right. And somewhere up there, I'm going to hit my graph eventually. So the way we do this is we say x is all numbers greater than where we start at. We start at 0. So I want x to be all numbers greater than 0. That's all things heading this way. So I don't have a compound because of this arrow on this line. Okay? That's a little confusing, but if you know about inequalities and I'm looking at my x's, I'll hit my graph starting at 0. No matter where I go out this way, I'll continue to hit my graph on the x-axis. Okay? When I go to my y's, now, oops, I erased my arrow, but that's okay. When I go to my y's, come on, there we go. I know range is y's, but I'm not going to have a compound because it's going to start here at -3, but I want to keep hitting my graph on all of these guys to infinity because, again, this line keeps going up. And so no matter how high I am up here, I'm going to keep hitting my graph. And so to say that, I say y is all numbers greater than, I start at -3, and I want all the numbers going greater than. And -3 is where it starts. Now, it's a solid line here, so I want the or equal to sign. So now we're starting to get into continuous graphs that sometimes only have one inequality sign versus a compound. Here I had a starting point and a stopping point on my graph. Here I have a starting point, but my graph doesn't stop. Okay, so we're growing a little bit here. Let's clean this graph off. That's why I did that. Now let's go to my f of 4. There's supposed to be an f of x there. That's what that's supposed to say, but I threw out my x and I put in a 4. So I go over to 4 on my x-axis, and then I go up and find my graph. It's right there's the dot where it crosses x on the 4. I look to the left and find my y value. It's a 1. All right? That's how you do it. Now, most of the time, we don't have graphs or tables and mapping diagrams. Most of the time, when we have a function, we have an equation here. But now, instead of an equation, we call this a function. This really means the same thing as y minus 4x minus 7. And this is where mental math comes in really handy because it's an f of x. They told me that. And so now down here, when they say find my f of 3, well, there's supposed to be an x there. I'm going to go to this equation and I'm going to put a 3 in wherever I see an x. Okay, so 3 times -4, this is where mental math comes in. Sometimes I'll write chicken scratch on the side. That's -12. -12 minus 7, 7, 8, 9, that's minus 19. I need to go turn my lights on real quick because my lights went off here. So f of 3 equals positive 19. I need to turn my lights on so I can see things here. It's timed, so it goes out if I don't move. I'll fix it here in a second. So that's what it means. Mr. Bishop could walk in my room right now and he'd be looking at my work and he'd say, oh, look, there's a 3 there. So that means Fisher put a 3 into some kind of a math problem. He did all the math and he got out a 19. Okay. Let's see if I can do this one real quick before I go turn my lights on and need my calculator. I'm going to put a -7 in for that x. I know -4 times a -7. This is where I'm losing some kids because they don't know the rule that a negative times a negative is a positive. And so they have to have their calculator still for this, and they're not still sure. Sometimes kids don't know what 7 times 4 is. This is where you start to fall behind. Negative times negative is a positive, and 7 times 4 is 28. So my chicken scratch over here would be 28 minus 7, because that term right there becomes a 28. 28 take away 7, what do we get? 21. Okay, so now they want my range here. They gave me 2 domains, and so now I need my range, and I want to put it in order. One of them's a minus 19, and the other one's a 21. Close my brackets. Okay, let's see if I can get away with another one before I go turn my lights on. I don't think I need my calculator for this one. Let's go down and do 16, and then we'll worry about our quadratics over here, okay? Let's do this one here. Nope, I want to need my calculator because I don't know, and without a whole lot of thought, what 12 times 7 is, okay? So give me a second here. All right, so calculator speeds up your math tremendously. but I'm going to have some little chicken scratch over here like this where I do my work. I'm going to use my calculator to assist me though. So I'm going to put this -12. These are my domains. Domains means my x's. It's just now in brackets here. I got 4 math problems here that I have to do. So hopefully most of it's kind of a mental one. I know a negative times a negative is a positive. So what I just need to know is what's 7 times 12. That's 84. So now I got 84 plus 3, which is 87. So I would recommend maybe writing your answers above this guy here because we're going to have to put them in order. So when I put in a -12, I got 87. And then I can do my range down here a whole lot easier, okay? You know what? I was just looking at my answer key. Did I mess up on this one? Let me look here real quick. 3 times 4 is -12. -12 plus 7. That's -19. That was right. When I put this -7 in, negative times negative is positive. That's 28. Yeah, 28 take away 1. I must have made a mistake on my notes here. All right, sorry, I digress. Let's go back to this one. -4. I know a negative times a negative is a positive, and I know 7 times 4 is 28. Now, 28 plus 3, 29, 30, 31, 32. I'm going to put a 3 in. Negative times a positive is a negative, so that's a -21 plus 3. -21 plus 3 is 21 take away 3 would be what? -18. Okay. And then my last one, I want to put 20 in. I don't know. Some kids know what 7 times 2 is, or that's a -40. Positive times a negative is a negative, and 7 times 2 is a -140. Plus 3. If I take 3 away from a -140, I'm going to have a -137. Okay, so now I have all my ranges right there. I just need to come down here and put them in order. -137, that's my smallest. -18 is next. Then I have a 32, and then I think that was an 87. Can't read my own writing with this fat marker here. All right, put commas in between. All right, so couple of tips. When you do the domains and there's many problems, write them up here, and then we'll write them into brackets here, okay? Let's see what we got here. So now these are quadratics. We spend a whole 9 weeks, maybe more, on just quadratics. Quadratic means it's got an x squared as my first term. That one has an x squared as my first term. We already talked about putting them in order at the beginning of the year. That's a degree of 2, degree of 1, degree of none. So this is in standard form right here. Nicely done. This one's in standard form. Nicely done. Now, I have an f of x. They're going to put a -4 here. So this one requires a little bit more of chicken scratch. And so I'm going to come up here. I'm going to rewrite the whole equation, but I'm going to put a -4 wherever I see an x. Now, you got to know how to do order of operation. We practiced that. We reviewed that at the beginning of the year. That's why it kind of got us a little bit behind. You got to do parentheses. Well, there is none, but I got to do exponents first. I can't do -3 times -4 is a +12 and squared. That's not how it works. It is not 144. I like to work with the first term here. This whole thing here and get my answer and put it underneath, and you'll get good at this. I got to do this first. -4 times -4 is a +16, and 16 times 3 is 48. But that's a +16, so 16 times a negative is going to give me a -48. Okay, so that whole term right there, I just did 2 steps at once. I got rid of my exponents and did multiplication and division. Now I see multiplication right here. I got -2 times a -4, which is +8 plus 1. So now, sometimes it's easiest to pick up your calculator and just say -48 plus 8 plus 1. And I'm getting a -39. So I'm going to put equals -39 here. I can't fit it in there. Okay. Now, 0 is always a good one in quadratics to put in because look at this. If I have -3, 0 squared, whoops, you'll get good at this, -2 times 0 plus 1. Well, what's 0 squared? 0. 0 times anything is 0. So 0 times -3, that's 0. -2 times 0 is 0. So I got 0 plus 0 plus 1. Okay, so you'll get good at that day. You don't even have to write chicken scratch. You'll just say, hey, 0 squared is 0 times -3 is 0. -2 times 0 is still 0. So 0 plus 0 plus 1. My answer here is 1. So now let's come up here and write my range. I got a -39 and a 1. Close my brackets. Okay, so there's my answer if I have it in f of x form and they give me the answer, or I mean my domains in my parentheses here is my x, but then I have to give the range for that problem. Okay, this one has 1, 2, 3, 4, 5 math problems all in this one problem. And this is what we're going to end up doing when we have to go to graphing. So we want to get kind of good at doing mental math here. Chicken scratch on the side. 2 times -2 squared minus 2 times -2, because that's what my x was. There's my x. So I'm putting in a -2. Sometimes I'll underline to make sure I know which one I'm doing. Plus 5. -2 times -2 is a positive 4. Positive 4 times a -1. That whole thing right there is a -4. So we've got to get good at this whole thing here. You got to put parentheses around it if you're using your calculator, but we should be so good at this that I don't have to put it in my calculator. I know negative times negative is a positive, and 2 times 2 is 4. That's a positive 4, and then times whatever's out front makes it back to negative. Right now, again, speeding things up. You should know a negative times a negative is a positive. 2 times 2 is 4. That becomes a plus 4. Plus 5. Well, my 4's cancel out, so this answer is a 5. So I would suggest writing the 5 right above it, so then we get down here. Let's put in the -1. I got 2 times -1 squared minus 2 times -1 plus 5. -1 times -1 is 1. Positive 1. 1 times 2 is 2. Negative times negative is a positive. 2 times 1 is 2. That's a terrible looking 5. Plus 5. 2 plus 2 plus 5. That's a 9. Okay. Put in a 0. Here's that 0. I'm not even going to do chicken scratch down here. 0 squared is 0 times 2 is still 0. -2 times 0 is still 0. 0 plus 0 plus 5 is 5. Let's put in that 1. 2 times 1 squared minus 2 times 1 plus 5. 1 times 1 is 1, times 2 is 2. -2 times 1 is 2, plus 5. My 2's cancel out. -2 and a positive 2 is 0, plus 5. There's another 5. And now my last one, I want to plug in a 2. 2 squared minus 2 times 2, plus 5. 2 squared is 4. 4 times 2 is 8. -2 times 2 is -4, plus 5. Notice I am not using my calculator for any of this. Hopefully, they're small enough numbers that we can do it mentally. 8 minus 4 is 4, plus 5 is 9 again. So up here I have 2 5s, a 9, and a 17. Okay, so let's put them in order. Actually, I have 3 5s. Where's my 17? I thought I have a 17 somewhere. I'm boo-booed somewhere. One of these guys is a 17. I got my work here, so let's go look at this. Sorry. There's a 4, because we did this yesterday. -4 plus 4. That guy is right. That guy is 5. You're probably yelling at me right now. -1 times -1 is 1. 1 times 2 is 2. Positive 2, 5. That guy is 9. That guy is right. We plugged in a 0. I know that guy's right. That's 1 squared. 1 times 2 is 2. -2, 5. I bet I messed up on this one. Always the last one. 2 times 2 is 4 times 2 is 8. -2 times 2 is -4 plus 5. Alright, where did I mess up? It's either this one or this one. I know you're yelling at me. I don't know where my brain is this morning. It's too early. 2 times 2 is 4. I plugged a 2 in. That's what I'm plugging in. So that's right. 8. Negative 2 times 2 is negative 4. Oh, here's where I messed up. There's no negative sign. Where did that negative sign come from? I have no idea where that negative sign came from. I was making a point, I think, right there. Okay, so this is the guy that's wrong. Negative 2 times negative 2 is 4. That's a positive 4. Negative 2 times negative 2 is a positive 4. 4 plus 4 is 8, plus 5, 8, 9, 10, 11, 12, 13. I'm still not getting a 17. All right. My notes say a 17 there. Let's look at some notes from yesterday. Sorry. Let's see what we got. Maybe I did this on the board. I think I did all these on the board yesterday. And maybe my notes is wrong again here. All right. For some reason, I have a 17 on my notes here. So if you're yelling at me saying, Fisher, it's a 17, it's a 17. I know this guy's wrong. Pretty sure this guy's a 13. I'll check one more time here. I put in a negative 2. Negative 2 times negative 2 is a positive 4 plus 5. That's 9, 10, 11, 12, 13. I like 13. All right. I might have made a mistake on this one. 5 is my smallest. 9 and a 13. Close my brackets. All right. So again, for some reason, I have a 17. 2 5s, 2 9s, and a 17 on my notes. So I'm thinking this guy's the one that's wrong on my notes. Wouldn't be the first time. All right. Crazy. Let's wrap this video up. I want to do, if I can, though, where's our practice lesson? There might be some notes on this from yesterday. Nope, good. All right, I'm pretty confident that you can do the domains and ranges up here pretty quick. These are brackets here because they're individual dots. Domains are right there, ranges are there. We're going to put them in order from least to greatest. But let's go down and do, I don't know, like a number 7. Now that you know function notation, that means put a 5 in there. So somewhere down below here, let's put a 5 in there wherever I see an x. So I got 2 times 5 squared minus 3 times 5 plus 8. Exponents first, so that's 25. 25 times a minus 2 is a minus 50. You're probably beating me done. Minus 15 plus 8. This is where I just pick up my calculator. Some kids can do that quickly in their head. It's too early in the morning. So I got negative 50 minus 15 plus 8. I'm getting a negative 57. So h of 5 is a minus 57. Put a negative sign in there. Almost forgot it. Now the rules up here say find a number, answer each question, and find your answer and cross out the letters above it. So my negative 57 is right there. So when I cross these letters out, that means that's not part of the answer. A 0 here, you might even not have any work here. Because I know 0 squared is 0. 0 times negative 2 is still 0. Negative 3 times 0 is still 0. So I already know that that guy's going to be an 8. Here's the 8 right here. Okay, so these are my two answers right now. They gave us one domain, a 5 and a 0, and they said find those using function notation. Okay, let's go do one on the other side real quick because this is where things get a little bit weird. I think we did number 11 yesterday in class. So h of x, this really means find my y's. That's what that really means. But if I look over here, here's my domain. So there's 3 math problems here. So I give you all this room to work here. So I want to put a 1 in for everywhere I see an x. 1 squared is still 1. 8 times 1 is 8. Minus 3. So now I got 1 plus 8 is 9. Take away 3 is 6. So I want to write a 6 right above that guy. Next one, they said put in a 5. So now I got 5 squared plus 8 times 5. Minus 3. That's 25. That's 40. Minus 3. At this point, I'd start picking up my calculator. 25 plus 40 minus 3. I got 62. Next one, I got put in a 2. Now, this is the one that kids always mess up on because they don't put it in parentheses. And so what happens is they get a -4 there. This is not a -4. So when I do this x squared here, I'm going to put it in parentheses. That's really -2 times -2 plus 8 times -2 minus 3. So this guy is really a +4. Minus 16 minus 3. 4 minus 16 minus 3. I'm getting a -15. So now I need to put these guys in order. My brackets down here is going to be -15, then a 6, and then a 62. Close my brackets. Now this is my answer right here. So put a box around it if you would. So it's nice and neat. If you're going to write them above like this, that's okay, but final answer needs to be in order, okay? Now I'm looking for a -15, 6, and 62 on the other side. Now on this came from an 8th grade paper, so they might not be in order. Actually, they're not in order. I can already see it. I think it might be this guy here. I had a -15, there it is. I have a 6 and a 62. There it is, CK. All right. So when you get to this side, each one of these math problems is just 3 math problems. So we got to kind of get good at this mental math and kind of chicken scratch is what I call it. I'm doing all my math right here, getting my final answer so that I can plot these points, because that's the next step is I want to start plotting these points tomorrow and on a graph. All right. All right. With that, now I have a video. I don't know where 20B went last year, where YouTube kind of lost it. But so I thought I'd record it today because there was a number of people absent yesterday. All right. Hope to see you today in class.